Okay, this video is about creating groups of data so that we can actually get an overview of what things we found when we went out. First one's on qualitative data. It's qualitative because there's no number associated with these. Even if you said red was marked 1, black was 2, those numbers don't actually have a meaning outside of them being linked to a colour. So the colours are the real data and they're qualitative. We could actually do this before we actually, and with most tally tables you can do this. You can actually create, rather than writing the list of colours, you can create a list of colours you would expect. These are the colours actually of what they've got. But some colours here, I wouldn't have thought of a car orange, so I wouldn't have had a list for it, entry for it. What I would have had is others. So some popular colours that I'd have predicted. So we read black, blue, green, silver. Missing white even. So I'd have expected white particularly around here. And a group for other. So if I don't see, if I haven't got a grouping for it, I don't need to record it on its own. I can group it in with others. Sometimes I would probably think, oh, I haven't thought. So white cars, I probably would create another group for white cars when I was collecting that data. And what we do is we cross off, or we record each time we see a red, we record each black. So we've got a black, and each time we see something on the screen, we can put a little tick mark. Now these tally marks come from counting on our fingers, and what happens when you get to 5 is a picture similar to your hand, and to show that you've got a group of 5 you put the line across the 4 fingers. We'll get one in a moment. And the reason we do that crossing is these barred gate ones, we know that's a group of 5, and it makes it a lot easier to count when we see our data. So we've got a group here, we've got the 5-bar gate, and we can count the frequencies. So top one, we've got 5 and 3 is 8, 5 and 1 is 6, 5 and 1 is 6, 4 tick marks on their own is 4, 5 from silver and other are 3. Now in there we've also got something called a modal group. Qualitative data only has an average of mode, and the mode is the most popular answer. We had 8 cars is the most popular, so the most popular, or the modal group, is red. That is the colour, the average. The average is always talking about the data being calculated. And there's our numbers. So into the next one. We're now moving into our quantitative numbers, and we've got some test scores here. Now these test scores are only marked out of 20, there's no half marks, so these numbers are discrete data. It only comes in particular values. And if you tried recording a tally of 1 to 20, that's quite a lot of groups to try and analyse. Also, what often happens is we've actually only got a small number of results here, so a lot of these will be either blank or very small. So what happens is we can create groups of scores that are similar to each other. So we've got scores 1 to 4, 5 to 8, 9 to 12, and these groupings should be the same width. If the groups aren't the same width, they haven't got the same number of values in them, potential values, you can introduce skewness, because it's not worth having one group of 4 and then pretty much 5 through to 15 as a group. It's an unfair balance for that group, and it will be a bias towards group 5 to 15. So we try and make them the same size as well. So these groups are 1 to 4, 5 to 8, 9 to 12. These are all groups of 4 different scores. So we're going to do a tally, and what you can do is, as we got the scores here, Again, we could do the tally as we collect the data. So as a student comes along, we could do the tally that way. Or often when you've got groups of data, you can often go through and just spot for each group. So I'm looking for scores 1 to 4. And we've got 1, 2. So we've only got 2 of them. So the frequency is 2. 5 to 8. 1, 2, 3. That looks like there's only 3 of them. So we've got 3 marks. Tally 3. 9 to 12. 1, 2, 1, 2, 3, 4, 5, 6. We've got 6 of those. So remember, we get the tally at 5, we put the bar in, and we put the 6th number across. 13 to 6, 16. 1, 2, 3, 4, 5, 6, 7. We've got 7 of those. Put the bar on, and 2 more. That's 7. And last bit, we got 1, 2, 3, 4, 5, 6 in the range 17 to 20. So I've got 6 scores, 6 marks. And to check it, we need to check how many numbers did we have. Now we had 6 rows of 4, so there were 24 people here. So I can check that these actually add up to 24. 5 and 6 is 11, and 7 is 18, and 4 is 24. I've probably got the right numbers then. So I check the tally, and it's corrected. The next sort of data, I think it goes on to the next one. Yeah, the next one is continuous data. Now, this has a... Okay, we're doing the tallies of the heights. This is continuous data. That means that often it's measured, and the sorts of thing that happens with heights is we could get heights of people who things like 130.8, 132.1, 145.6, and 137.8, and this is centimeters. Recording each one of those with a tally, you're going to wind up with a lot of them which are only of their own size. So we create our groupings again. And to create the groupings, it's often look at the smallest value and choose sensible, reasonably round numbers to say this is going to be between these two values. So for this, I would probably do a group that goes from 130 to 135. But this 135, anything fractionally more than that needs to be able to go into the next column. So both of these are limits. Look, traditionally, what we do is we say, always put the higher value, the value in the higher group. It is possible to do them differently, but this is now saying that this is a group of heights, 130 centimeters to 135, but not including the 135. The 135 goes into the next group. And what I would probably keep doing is keep going so that the groups, again, are similar widths. If you have different width groups, you can distort the data and your conclusions become less reliable. So we're going to try and create separate groupings that are the same width, same number of range and distances. So 135 minus 130, it's 5, it's 5, it's 5, and it keeps going that way. So that's what they're doing here, is they're going to put in a set of different heights using inequalities, and they go on to explain the same thing, that this grouping means from 30 to 40, but don't include 40. This is the most traditional way to do it, and we keep building up. So now we can start putting our heights in. So notice only one of them has an equals, and normally it's in the higher group. So we've got to put these into here. So I'm going to do the same sort of method as I did before. We have 20 numbers there, and I'm going to look for numbers in the range of 30 to 40. So we've got 30 to 40, there's 1. The 40 goes into the next group, so I ignore it for this time. 2, 3, 4, 5, 6. So there are 6 in that tally, and I'm going to tally them. 1, 2, 3, 4, 5, and put a 6th one in. Now, traditionally, you do all the tallies first, and you can record people's heights straight into the table if you need to. That way you haven't recorded all these numbers, and there's a lot of writing involved in this. So now I go back through the 40 to 50. So anything that's 40 but not 50. So 40 as 1, 2, 3, 4, 5, 6, 7. There's 7 of them in there. The range 50 to 60, but not including 60. So 1, 2, 3, 4, and 60 to 70, 60, 60.2, that's 2 of them, and more than 70 but less than 80 is only 1. So you have to have an idea of what your data goes from and to be able to put this number of groups together. Once you've done the tally, you can put in your frequencies, how many there are of each lot. And again, quick check, we've got 4 by 5, there are 20 dogs, they told us that at the top. This should add up to 20. 6 and 3 is 13, 6 and 7, 13 plus 4, 17, 19, 21. That's probably okay to mark it. And if we have a look at it, again, we can talk about a modal group. The modal group is the most popular size of a dog, that's 7. So the group is the data value that went with it. So that's 40 to 50. Okay. We don't say the modal group is not the frequency, it's the data value that's the most popular. Quick summary of these groups. So 30 less than or equal to H less than 40 says smallest number is 30 up to 40, but do not write 40 in this group. This one does it slightly the other way around. This isn't as common, but it's anything from 60 to 70, not including 60, but including 70. That's the last bit of this. And we're not going to do the graph part now.